Hello, everyone. Today we would like to continue our lesson on Nuclear Chemistry 1. In our previous lesson, we found out that Henry Becquerel discovered radioactivity. We also discussed radioactivity as the process in which an unstable atomic nucleus changes into a different nucleus with the emissions of radiations which carry energy. We described what was meant by transmutation reaction, whereby one chemical element is converted into another chemical element. We also discussed the two main types of radioactivity, artificial and natural radioactivity. We also saw a brief discussion or a brief explanation of how to balance nuclear reactions, and then we discussed the differences between chemical reactions and nuclear reactions. In today's lesson, we will talk about the three main types of radiation. For each radiation, we'll look at the nature, what the radiation is made up of. We'll also talk about the charge and mass of the radiation, the penetration power of the radiation, ionizing or ionization power of the radiation, and effects of electric and magnetic field on the radiation. Let's look at the types of radiation. The three main types of radiation that we have are alpha radiation, beta radiation, and gamma radiation. Alpha radiation. Alpha radiation consists of helium nuclei that have been emitted from a radioactive source. The symbol, we can use the Greek alphabet alpha, or we can use He, which is the symbol for helium. Atomic mass, we have the mass before atomic mass unit, and the charge is 2 plus. So helium atoms, written as this, is the symbol for alpha radiation. We want to find out the penetration power and the ionizing power of alpha radiation. If we talk about the penetration power, we want to find out the ability of alpha radiation to penetrate or go through substances. If we look at the penetration power of alpha radiation, it has low penetration power. Alpha radiations are not even able to pass through a single sheet of paper, and it travels for only a short range in air. Ionizing power of alpha radiation. Alpha radiations are positively charged. We've already seen that they have a charge of 2 plus. When we talk about ionizing power of a radiation, is the ability of the radiation to produce ions in gases. Because alpha radiation is positively charged and they are heavy, they have very high ionizing power. This means that it can produce large numbers of ions as they penetrate or travel through gases. The effect of electric field on alpha radiation. Alpha radiations are positively charged, and because of that, in an electric field, they are rather attracted towards the negative electric plate and deflected away or repelled away from the positive plate, because you remember, unlike charges attract and like charges repel. In the magnetic field, alpha rays are deflected slightly in one direction in the magnetic field because they are heavy and positively charged. Beta radiation. They consist of fast-moving electrons, represented by the Greek symbol beta, or E as the symbol for electron, with a charge -1 and a mass 0, or 1 over 1837 AMU, atomic mass unit. This mass is similar or equivalent to the mass of the electron. If you remember the mass of the electron, it is 1 over 1840 AMU. So beta radiations are just fast moving electrons. Beta radiation has very good penetration power. It can pass through a few centimeters thickness of aluminum foil. So it means beta radiation can go through a paper and even pass through a few centimeters thickness of aluminum foil. If the aluminum foil is very thick, it cannot pass through. It has low ionizing power compared to alpha radiations. Alpha radiations have high ionizing power, but beta radiations will only produce few ions in gases when it passes through. Beta radiations are negatively charged. They are fast-moving electrons. So in an electric field, they will be attracted towards the positive electric plate and deflected away from the negative electric plate. Beta radiations, because they are negatively charged, they are also deflected strongly in the opposite direction of the magnetic field because they are also not heavy, they are light in nature. We'll look at the last type of radiation, gamma radiation. Gamma radiation consists of electromagnetic wave. We use the Greek symbol gamma to represent gamma radiation. It has zero charge and zero mass. Gamma radiation has very high penetration power. It can pass through wood or human body. If you want to stop gamma radiation, you use lead block or several feet of concrete or several inches of concrete to stop gamma radiation. So gamma radiation, when you are exposed to gamma radiation, it is you are at a risk of being exposed to the effects of radiations. Ionizing power. Gamma radiation has very low ionizing power. In some books, they will say that it has no ionizing power or gamma radiation is not ionizing. But here we will say very low. I will explain the reason why we are saying very low. So in most books, they'll say it does not produce any ions in gases. It produces ions in gases, but if you compare the ability of gamma radiation to produce ions in gases, when you compare it to beta and alpha, it means that gamma, the ionizing power of gamma is very low compared to the first two. And the reason is because it is not electrically charged. Gamma radiation has a charge 0. Effect of electric field. For an electric field to act on a particle, the particle must be charged. Gamma radiation has no charge. So gamma radiation is not affected by electric field. The same thing, it is not also affected by a magnetic field. Let's look at a few diagrams to explain all that we have discussed today. On your screen, I have an electric field with two metal plates. The positive plate here on your screen is the anode and the negative plate here is your cathode. I have a radioactive sample put in a lead shield or a lead block. Now gamma rays, when it passes through an electric field, it will pass through straight, move straight, undeflected in its path because it is not affected by the electric field because it has a charge 0. Beta radiation, on the other hand, will be attracted towards the positive plate because beta particles are negatively charged and unlike charges attract. When you come to helium atoms, the alpha particles, they will be deflected towards the negative electric plate because the alpha particles are positively charged. Another diagram to explain the penetration power of alpha, beta, and gamma radiation. Now on your screen, we have three mediums. We have paper, aluminium foil, and lead. Alpha particles or alpha radiation will be stopped by just a sheet of paper. It can't even pass through a sheet of paper. So it has very low very low penetration power. Beta radiation can pass through paper and a few inches of aluminium. So this is an aluminium foil. It is thick, so beta radiation cannot pass through. It is just a few centimeters thickness. It could have passed through. Gamma rays or gamma radiation has very high penetration power. It can pass through paper, aluminium foil, even human body. It can only be stopped by a lead block. So you see the thickness of the lead block, a lead block or concrete. So I have also another diagram to explain that. So we have the alpha rays passing through paper, beta rays passing through but cannot pass through the aluminium. Beta rays can also pass through the human body. Gamma rays passing through the human body, aluminium stopped by lead. We have another type of radiation. This is just additional information. Neutron rays or neutron particles. For these particles, they can pass through the paper, human body, aluminium, lead. It can only be stopped by water. So if you realize when you watch movies, when the actors are exposed to radiation, they run and go and um, dive in water or water bodies, a river or something, so that they would not be exposed to the radiation. Magnetic field, the effect of magnetic field on radiation. We have the alpha, beta, the third one moving straight is the gamma radiation. It didn't appear here, but here it's supposed to be gamma. Beta radiations are deflected slightly in the opposite direction. So if you see it, it is going to opposite the magnetic field. But alpha radiations are deflected in one direction. They are moving in the direction of the field. So that is the effect of magnetic field on alpha, beta, and gamma radiation. The last diagram we want to look at is the ionizing power of radiations. I already explained what it means if we say a radiation is ionizing or ionizing radiation. It is the ability of a radiation to remove an electron from atoms so that the atoms can be converted to ions. So on your screen you have an atom, I have an electron, and then I have an energy source. You remember that we said radiations carry energy. So the incoming radiation will come and knock off electron from the atom. If an atom loses an electron, it becomes charged, normally positively charged. So that is the ability of radiations to produce ions, especially in gases. So that is what we describe as the ionizing power of radiations. We also said gamma rays are ionizing. Some books say they do not produce ions. They do, but it's very few compared to alpha and beta radiation. Actually, they are not supposed to produce ions, or they are not supposed to be ionizing, but they are. Why? This is the reason. Gamma rays are part of a type of radiation known as electromagnetic radiation. We have a lot of electromagnetic radiation. On your screen we have the radio waves, microwaves, infrared, visible light, ultraviolet, x-rays. Now these radiations, they are not charged like the gamma rays. It has zero charge, zero mass. So if you are not charged, you are not supposed to be ionizing. But gamma rays are ionizing because they have high energy. In books or from literature, gamma rays have 100 kilo electrovolts. That is the energy of gamma rays. So because the energy is very high, they are able to knock off electrons from atoms, thereby producing ions. If even it is very few ions, they are described as ionizing. So because they are found on they are the high electromagnetic radiations found here, X-rays, gamma rays, they are ionizing because they have high energy. So X-rays are ionizing, gamma rays are ionizing. X-rays do have zero charge, zero mass, gamma rays zero charge, zero mass. Okay, so this brings us to the end of our lesson. Thank you.